All right, guys, I'm going to just go ahead and show work for example 5. So if you notice for example 5, guys, these are conjugates, and you really have to be able to identify those when they appear in our work. Remember, when those factors are multiplied together, you're going to get a difference of 2 squares. Conjugates always multiply together to get a difference of 2 squares. And also, after we multiply, that's a property, guys. The 1 is just moved over. So this equals exactly tangent squared. So that was a pretty basic problem. I just wanted to point that out to you guys. Same with number 6. Let's look at number 6 down here. Again, these are conjugates. So when they multiply together, it's a difference of 2 squares. And remember, this is an actual property. What's going on is this tangent was just moved over. So these two subtracted together does equal 1. So remember, when you see these conjugates, those are going straight to a difference of 2 squares. All right, let's go ahead and talk about this problem right here. So for example 7, actually, you know what? Both sides of the equation look pretty complicated. However, tangent's one of our main trig functions like sine and cosine, so I'm going to leave that alone. I'm going to focus on rewriting these because they're reciprocals, guys. So the first thing I did is I noticed I could factor. So I took out secant squared. So when I took out secant squared, I only had 2 of those left. And remember, when you take out all of something, a 1 is in its place. This is a difference of 2 squares, which means it's probably an identity, and it is, guys. All that's happening here is that 1 has moved over. So inside those parentheses, this is going to just be tangent squared. Inside of the parentheses just turns into that. Let me recopy secant squared. Okay, so we're going close to the right track, but everything is in tangent. What's going on with this? Let's see what we can do. Well, if you notice just right above, what does secant equal? It equals 1 plus tangent, and we want these to be tangents, so I'm going to replace secant with 1 plus tangent. So 1 plus tangent squared times what was already in the parentheses of tangent squared. Let's go ahead and distribute this. We're going to distribute this to both. So tangent squared times 1, of course, is tangent squared, plus tangent squared times tangent squared is going to be tangent to the 4th power. And there we go, we did it. It's in the opposite order, so I'm going to rewrite it with the highest exponent first. So this is going to be tangent to the 4th of theta plus tangent squared of theta, and of course that's going to equal what the other side was. So we have, whoops, that's a plus sign. So we have identical properties. Almost ran out of room there. So that is going to be the answer for number 7. Okay. Whoops, goodness. A lot of examples on here, guys. This is going to be a try on your own, but you know what? I'm just going to help you get started a little bit. So don't be fooled. These are not conjugates. They're not stuck together. There's a plus sign in the middle, and both of these are squared. And remember, when you square something, it's like a perfect square trinomial. So what's going on here, guys, to get this started for you? It's 2 of these multiplied together. I'm just kidding. We're not trying this on your own. I'm going to do this with you guys. I want to do this one with you guys. All right, so I am just working on this first piece right here. Sine times sine is sine squared. Sine times cosine is put together. These 2 are put together. When I multiply the outside and the inside, they are like terms. So it's going to be 2 cosine times sine. Cosine times cosine is cosine squared. So that's that first piece. This second piece is going to behave the same exact way, guys. So this second piece still starts out with a positive sine squared. And then when I multiply the 2 outside and the 2 inside together, they're going to be like terms, just like what happened here. But remember, these had 2 pluses. When I multiply these together, these are going to have 2 negatives. So the two outside and the two inside are going to be negative cosine times sine. And then, of course, our two last terms are negative, but remember, a negative times a negative is a positive. So that's still going to be plus cosine squared. Okay, so from here, we need to figure out if we have any like terms that are going to cancel, and we sure do. I have 2 cosine sine and negative 2 cosine sine. So these are going to cancel. What else do we see here? We actually have 2 of these. Those are like terms. And then we have 2 of these. Those are like terms. So let's add our like terms together. So 2 sine squareds. That takes care of that. These 2. There's 2 of those that are alike. Whoops, I forgot my 2. 1, 2. There's 2 of them. Let's factor out a 2. And there you go. That's how we're going to get that to go away, because that's an identity that just equals 1. So there we go. 2 equals 2. So please remember, and I'll just write it again down here, when you have something, and I'll just make it simple terms like x plus y. X plus y raised to the second power, remember, is x squared plus 2xy plus y squared. That's always the rule for that. And of course, if you have a subtraction binomial that's squared, the first term and the last term, they're always positive. But my middle term is just going to be whatever that sign is. It's going to be double that. So please remember, these are called perfect square trinomials, by the way. Pretty important we have that and we recognize what that is. All right, let's move on. So for example 9 might be one of the ones where you might get stuck on. So please, please, please write down this little hint right here. What we're going to do is we're going to take our single fraction. So we know how many fractions here. We have a single fraction here. We're going to multiply this by the conjugate and then see what we can do with it first. And guys, the reason why we multiply by the conjugate is it gets rid of the fraction. And you'll see what I'm talking about in a moment. So if one side is not a fraction and the other side is a fraction, this is the way to go. All right, so I'm going to leave this alone. I'm only going to focus on this side. So we're going to multiply both sides, or the top and the bottom, by the conjugate, which is going to be 1 minus sine. Okay, so the top is going to be cosine times 1 minus sine. I'm not going to do that math quite yet. But look, guys, again, these are conjugates. They are factors of a perfect square trinomial, or a difference of 2 squares, not a perfect square trinomial, a difference of 2 squares. So that's just going to be 1 minus sine squared. When I multiply those 2 together, you get that. Y'all, that's an identity. That's going to equal cosine squared. I'm recopying the numerator, by the way, right now. Remember, that equals cosine squared. Now, if you notice, this cosine is going to knock off one of these. There's 2 of them down there. There's one up here. So now what we have is 1 minus sine over cosine. So let's split these up and see if we can rewrite it like that, which we can. So look, guys, 1 over cosine minus sine over cosine. There you go. That's going to be your secant, and that's tangent. So we're almost done. So this is secant theta minus tangent of theta. I'm just going to bring down this other side. Secant theta minus tangent theta. We are so good. They both are identical. And we verified that trig property. All right, you're done. Way to hang through to the end of these notes. guys, please show me in class. And then you do have homework. It is, the key's already available for you, and you're just going to show me that next class period. And then that's going to be it.